Okay, so now we're going to work on page 39, which is in your Chapter 10, Part 2 packet. We're working on 10.6, which is solving quadratic equations using the quadratic formula. So now, the quadratic formula is x equals negative b plus or minus the square root of b squared minus 4ac all over 2a. Now, I want you to look at that, especially the first part. What does that look like? X equals negative b over 2a. Well, that's the axis of symmetry. And what this is saying is that from the axis of symmetry, you add and subtract the same thing. So if this is your axis of symmetry, whatever you do on this side, and hence you have the parabola and it's symmetrical. So this is the quadratic formula. Now, before you use the quadratic formula, you should always set your equation equal to 0, and you should always identify a, b, and c. Now, why would we use the quadratic formula? Well, you can use the quadratic formula to solve any quadratic equation. So far, we've learned we can solve quadratic equations by setting everything equal to 0 and factoring it, and then applying the zero product property rule. But sometimes equations can't be factored using integers. We also can solve by completing the square, but sometimes when a is not 1 and b is an odd number, it creates unfriendly fractions, so we don't want to use completing the square. We can also solve by square rooting both sides, but if b has a value, square rooting doesn't work. So when factoring is not an option, when b is not 0, and when a is not equal to 1, a lot of times the easiest way to solve is to use the quadratic equation. So here's an equation in example 1. First thing I'm going to do is subtract 3x from both sides and set this equal to 0. So this would be 2x squared minus 3x minus 5 equals 0. Now, I identify a is 2, b is negative 3, c is negative 5. Now I plug things in. So we do the opposite of negative 3. Negative 3 squared minus b squared minus 4ac. So a is 2, c is negative 5, all over 2a. A is 2. So this becomes the opposite of negative 3, or 3, plus or minus, negative 3 squared is 9. 4 times 2 times 5 is 40. The fact that it's minus a negative means I add, so this is 9 plus 40, which is 49, all over 4. Now the square root of 49 is 7, so 3 plus or minus 7 all over 4. So that's 3 plus 7 all over 4, which is 10/4 or 5/2, or 3 minus 7 over 4, which is negative 4 over 4, which is negative 1. So we get two answers, 5/2 or negative 1. Okay, so let's turn the page. We're going to do one more together, and then you're going to try to do these on your own. So for example 1, this is exactly what we just did. So I'm going to let you try that one again on your own without looking. So let's do this one together. So the first thing I'm going to do, 2x squared plus x, I'm going to subtract 3 from both sides, set it equal to 0. Then I'm going to identify a, b, and c. So in this case, a equals 2, b equals 1, c equals negative 3. The quadratic formula is x equals negative b plus or minus the square root b squared minus 4ac all over 2a. So this is going to be x equals negative 1 plus or minus the square root of 1 minus 4 times 2 times negative 3, all over 2 times 2, which is 4. Now notice again, This is minus a negative. So that's going to be plus. 4 times 2 is 8. 8 times 3 is 24. So this ends up being x equals negative 1 plus or minus the square root of 1 plus 24 all over 4. This ends up being negative 1 plus or minus 5 all over 4. Now I find the easiest way to do this is always break it down into negative 1 plus 5 over 4, comma, negative 1 minus 5 over 4. This becomes 4 over 4, which is 1. This becomes negative 6 over 4, which is negative 3/2. Okay, so now what I want you to do is you're going to work on example 3, 4, and 5 on your own. And when you're done, start the video again and check your answers. Okay, so I'm going to show you the answer for number 3 and all the work. We get A equals 3, B equals negative 1, C equals negative 16. You can see where I plugged everything in, except this time, because I ended up with the square root of 193, which is not a perfect square, I rounded that to the nearest hundredth, and so my answers there are rounded to the nearest hundredth. Now, if you were asked to round to the nearest hundredth, you'd give me 2.48 and negative 2.15. If you were asked for simplest radical form, which we really haven't learned yet, you'd leave it like that. So that's the answer to number 3. Here is the answer to number 4, which again, if you were asked to round it to the hundredths, there it would be. And then what happened with number 5? Well, in number 5, you ended up with, underneath the radical, you had a negative number. And guess what? There is no real solution because we don't have in the real number system an answer for the square root of a negative number. So when that number under the radical sign is negative, your solution is no solution.